This video will give a brief introduction into the simplest computational model, or automata, that we will present in this course, the finite state machine. For this video, you should remember what we mean by a symbol, an alphabet, a string, and a language. Many of the problems that we encounter as computer scientists can be modelled as language decision problems. That is, the problem reduces to deciding, given a string from an alphabet, is that string an element of a language or not? In order to be able to do this automatically, we would like to be able to build a machine for any such given language, which will take strings as input and tell us if they are in the language or not. When we are building these machines, the terminology we will use is that if a machine returns yes for a string, then it accepts that string. And if it returns no, then that machine rejects the string. So the machine accepts if W is in L and rejects when W is not in L. The simplest of these machines that we will talk about in this course is the Deterministic Finite State Machine, or DFSM. It consists of a finite bunch or set of states, ways to move in between the states, which we will call transitions, a special state in which we always start the machine whenever it does a computation, and a few special states which the machine uses to decide if it accepts the given string or not once computation is finished. The states of a finite state machine represent all of the information that the machine has about the history of the computation. As you can tell from the name, a finite state machine only has a finite number of these states, and it is considered to be in one and only one state throughout the computation. We represent them by circles on the diagrams, and they should always be given a name. There are no hard and fast rules about the names that we can use, but convention is often to use P or Q, possibly with subscripts, or you can also use letters, numbers, or if you are describing a particular problem that you're modelling, perhaps descriptive names are best. So states of a student listening to this video may be engaged, hopefully, bored, hopefully not, or asleep in the worst possible case. So we have the states that the machine can be in at any time, and we need ways for the machine to move between these states, or transitions. These are represented in our diagrams by arrows, and are always labelled with one element from the alphabet of the language that the machine is trying to decide. They can move between two distinct states, or loop from a state back onto itself. We designate one of the states of the machine as a special start state, and this is the state that the machine begins all of its computations in. On the diagrams that we use, we represent this by an arrow coming from nowhere into that state. So in this particular instance, the start state would be state Q0. A finite state machine also has a subset of its states which we call the accepting states. These the machine uses to decide, when it has finished computation, whether or not it accepts the string that has been given. On the state transition diagrams, we represent these by having two concentric circles for the states symbol. So in this particular instance, the accepting states for the machine would be the set Q0, Q1. Now that we have an informal description of all of the parts of a finite state machine, we can talk about how they operate. A finite state machine, when given a string, reads that string one symbol at a time from start to finish. So the first symbol that this machine will be dealing with is the letter A. It reads these in one at a time and consumes them, following the transition coming out of its current state that matches that symbol. So, the start state for this machine is Q0. The first symbol that it will see is the letter A, and the transition matching that is this one. So, the machine will consume this symbol and move to state Q1. The machine will then see the letter B as the next symbol and will follow the transition out of its current state, Q1, that matches that, going back to state Q0. Then it'll follow the transition back into itself, transition to Q1 upon seeing an A, transition to Q2 upon seeing an A, follow this transition, which it can follow on seeing either an A or a B, until it is finished. When the machine has consumed all of the symbols from the input string, it accepts the string if it is currently in an accepting state, or if, as in this case, it is in one of the remaining states, it rejects the string. As an exercise, you might like to pause the video and decide whether you think this machine will accept the empty string, the string of just an A or a B, or the string AA, B, BB, AA, B. So, having finished this video, you should know what a finite state machine is informally, particularly the states, transitions, and the concepts of accepting and rejecting strings, and how to trace through the operation of a deterministic finite state machine given its graphical model.